Thank you so much for the introduction. I really appreciate being here. It's an absolute pleasure. Before I get started, I just, this is a day when we really when we talk about open research, this is a day when we celebrate research. And I'm afraid that many of you will be aware of the fact that with the difficult financial situation at many of our campuses, research is, or I perceive it, and many of us perceive it, as being under threat. And I'd like to just mention something that I have seen a lot happening at the moment, and that is a false narrative that I think is being widely spread around many of our campuses about something called underfunded research. This is, what I kind of perceive is that when, for instance, I create a project which is externally funded by, let's say, UKRI, and I put a research associate on it, then the cost of the research associate might be, let's say, 60K. The project with overheads might cost 150K, and the grant might be, let's say, 120K. This is something that would be perceived by many of our universities as a 30,000 lost, basically, to research. And that is a completely false narrative, because this doesn't account for, of course, the innovation potential that research really brings to our campuses, that research brings to teaching. It doesn't account for also the ref return, which is actually cash return of money that comes back to our campuses. So what I wanted to just say before I even start, I wanted to fight this sort of false narrative, which I think is which is very, very bad for all the research that is being done across the UK, across lots of UK universities. And I think we need to fight it with facts that research is important. It brings innovation to universities, brings innovation to teaching, and it's absolutely key to the mission of our universities. And with that, I'd like to continue. And I do apologize for this, because our institute is currently being under threat exactly due to this narrative. So my name is Petr Knoth. I'm here with David, and also I will be presenting work of one of my research associates, Dr. Sucheta Nambanor-Knoth, who has done one of the pieces of the work that we will cover today. I will introduce the core. I will tell you a little bit about why it's important and why we really care about machine access to research content, why that is key, and then I will talk about these three projects which were already mentioned. And towards the end, I will talk about opportunities and challenges. And the part about CORE-GPT will be presented kindly by David. Let me tell you a little bit about our research group. Our research group is called Big Scientific Data and Text Analytics, but many people know us as the CORE, or Connecting Repositories group. CORE is well known for being one of the largest, or if not the largest, comprehensive database of research papers, or open access research papers more specifically. We have 42 million full-text research papers directly hosted in CORE, and we provide access to metadata records from across the globe, with about 360 million metadata records today. Our team is really interested in not just sort of indexing this content, but also by sort of developing in the development of services and that sort of improve discoverability, accessibility, and reusability of this content. We work both with universities as well with some, and we are also supported by some commercial partners who use research content to do very important things for the society, such as, fact checking, for instance, is something that I would really like to highlight as a very important tool where research content plays an important role. So overall, the key topic of our group is about providing seamless access to open research for both humans and machines. And very often people understand the part about why humans need access to research papers. But with the sheer volumes of scientific content, we need to understand that humans will not be able to read everything, and therefore we will rely, and we will continue relying more and more on technology to help us read, access, and find effectively the relevant research content that is important to us at a particular point in time. And with the advancement of artificial intelligence, I believe that many of you will be aware why for machines being able to read research content is very important. What's the mission of CORE? So the mission of CORE is really to create a comprehensive index of all open research around the world. We have lots of users on the website, and we want to do it not in isolation, but we are absolutely committed to doing it together with the community. So we are a not-for-profit scholarly infrastructure that is completely dedicated to the open access mission. We're also adopters of the principles of open scholarly infrastructure, or so-called POSI principles. And we are here to serve the global network. And a lot of the services that we build on top of CORE, we build together with the network of repositories. So we apply often things like, like co-creation methodologies. And with that, I think I gave a brief introduction, and I'd like to hand over to David, who will enter the first part of the talk.
Greetings, everybody. Fantastic to be here. Let me just make sure that I've got everything set up and you can hear me. Hi, my name's David Pride. I'm one of the researchers here at CORE. I've been here 9.5 years now, which is kind of scary. I was Petr's PhD student originally, and I'm now a postdoc researcher working in CORE. One of the projects that we worked over recently is this idea for CORE-GPT, and I'm sure everyone in the call is aware of the GPT models and the massive transformation that happened a couple of years ago. And the work of CORE-GPT is essentially taking those large language models and combining them with the content we have in CORE, which at the moment runs to about 40 million full text papers. First slide, please, Petr. So what we did at the start of this, now they're getting better is the bottom answer to this, but we tested this when we first looked at this project a while ago, and we asked, this was GPT 3.5 and 4. We asked 500 different questions, and we asked it to cite the sources for the answers to those 500 questions. And at the point we did this study, it very, very confidently gave an awful lot of wrong answers. In fact, you can see that fictional and other ones that are made up conflated are the interesting ones, really, because that's where it would take a real journal title or a real paper title, but it wouldn't be what it had referred to in the answer. It was a complete false narrative still. And these are, of course, these are hallucinations. And the common cries, yes, but this is not what they're generative models, but they're not what they're designed for. And I have a slide that can show you 20 different examples in the legal profession, in the medical profession, in the scholarly domain, where people have relied on citations generated by GPT, and these have turned out to be entirely false and inaccurate. As I say, with GPT-4 and now GPT 4.5, they are getting considerably better, but they are far from perfect. So something came out a couple of years ago that was introduced that we worked on. I worked on with Matteo Cancelleri, who's the lead developer of CORE, and it's called a RAG framework. And next slide, please, Petr. And we put this together into what we call CORE-GPT, and it's a Q&A platform that uses an LLM in a couple of different stages to query the 40 million plus documents that we have within CORE. And the way this works is, next slide, thank you, is a two-stage process. And so we take a user's question, and this is clearly a naturally phrased question. And the first thing we do is we turn that into an Elasticsearch query. And Elasticsearch is just the way the search across the servers works in the background in CORE. From that, we return the 5 most relevant papers for that question. And then the bit where the RAG comes in, which is what's called Retrieval Augmented Generation, is you take the content of those papers and you then provide the model with those papers with boundaries. And you say, using only the content that has been provided, please now generate the answer. And within the answer, give me the citations to the papers from which that answer is drawn. And the effect of that is twofold. First off, you know the papers are real. You know the answer you're being given is grounded in scientific research. And the second reason for that is if the model is carefully framed to only answer on the provided content, if the question is unanswerable with the provided content, the model will say so. It will tell you that it does not have enough information to provide an answer on the content given. It won't then make up some completely random answer. Next slide, please. And so here we have an example is what is the effect of changing composition of metal alloys on their mechanical properties. And you can see the opening sentence is pure GPT, but then it goes, for instance, in the 15 something alloy, exposure to intermediate temperatures can cause embrittlement through the martensitic decomposition. I even had to check that that was real because I'm not a chemist, etc. And you can see there's your answer, and underneath are the 5 papers that that answer is drawn from. And if we go to the next slide, I've missed one out. My apologies. Go back. I'll talk about the next slide. I'd skip one there. There was just an example that showed the paper that it was drawn from. The other thing that this does is if you've used language models at any point in the last year or so, you almost will undoubtedly, and again, this is improving, the answer will be phrased with, I'm very sorry, but as a large language model, my knowledge cutoff is X. And originally this date would have been November 2022, and then it was September 2023 when these models are updated. There has even been examples of research papers that have included this statement, which is pretty poor copy editing if anyone comes across that. One of the advantages with CORE-GPT is you do not need to retrain the model to get up-to-date answers. Because the answers are drawn from CORE, CORE is constantly aggregating content from 12,500 repositories. Once the content is in CORE, it can be used by CORE-GPT to answer questions. Next slide, please. I've got to move on quickly because I'm on a very tight time here. This was tested with 3 different evaluators across 3 different rankings. We asked them to rank the answers on comprehensiveness, trustworthiness, and utility. So how well-rounded is the answer? Do you believe the answer? And how useful is the answer to you? And you can see overall, particularly in the hard sciences, the questions were very good. It wasn't so good in some domains. If we go to the next slide, please. We got a quick example of the results here. We can see, and this is for the answer quality. You see, it scored very, very highly in some domains, not as well in some others, but still not bad at all. One of the interesting notes about this graph is that the trust is the yellow score, and because of the nature of the system, people tend to trust the answers because they know they're based on scientific peer-reviewed literature, which means even when the answers were deemed to be less comprehensible, less useful, the trustworthiness of the answer actually remained significantly high, which is a real positive for the system. Next slide, and then I think I'll wrap up quickly after this one. Citation relevance. How relevant this is really a test of CORE, because this is how relevant are the papers that we're returning in terms of answering your question, and in terms of how we rank the papers as well. If your ranking algorithm works well, then logically the first paper that's returned should be the most relevant, the second, the third, the fourth, the fifth, etc. And you can actually see by the mean correlation stats here, but by the mean scores, you can see that's exactly how it does work. So you get cited answers, really nice trustworthy answers with far fewer hallucinations than you get in a standard LLM. And the last slide is the wrap up. And that's perfect. That one there's perfect. If we can skip to the next one, because otherwise I'm going to run out of time. Thank you. Sorry, Petr. So we have CORE-GPT. GPT models are expensive. We're currently doing a test with things like Llama and some of the open models and Mistral 7B and those, because CORE is currently used by 30 million people a month. And to be frank, if we rolled this out to every one of those people, we'd single-handedly bankrupt the Open University, and I don't think they'd let us do that. So we're working on models to bring this to a wider audience. We're also working on what we can do with it and having a conversational agent, putting it as part of the API system, having it as part of the recommender, which is already used by the Open University as within Oro, which is the Open University's repository. You can use the core engine behind that. And yeah, fantastic, really exciting piece of work. Just wish we had more time to do these kind of things. And I hope that was interesting. I'm open for any questions at the end. And at this point, I think I should probably hand up to Petr, because I'm just about out of time.
Thank you so much, David. And what I will attempt to do now is I will tell you a little bit about the next project, which is about automating the classification of research outputs into United Nations Sustainable Development Goals. In this case, I will actually use the slides very loosely, and I'll try to, or attempt to, give you a little bit of a demo towards the end of this section. And then there will be one more section about reproducibility of research. So this project is effectively something that we've been doing. It's a one-year project which has just finished, basically, and it has built a dashboard for universities to understand the contributions that these universities are doing towards the United Nations Sustainable Development Goals. Why is this important? And also I want to mention, actually, before I get there, what David talked about is actually, for those of you who know a little bit deep learning, you will know that GPT models, these large language models, they are so-called decoder models. Then there are other models which are called encoder-decoder models. And then there are models which are called just encoders. And in this case, I'm going to be using encoder models because they are incredibly efficient in tasks which are related to classification. So why is SDG classification important? Why does it actually matter for us? The society needs to make progress towards United Nations Sustainable Development Goals. 17 goals have been formulated, and in order to make progress, I believe that it's very important to be able to monitor it. If we can't measure a particular variable, then it's very hard for us to demonstrate and also sort of work towards improving it. And what I understand is that many universities, not just the Open University, are here working a little bit in the dark because we produce a lot of research, but we don't necessarily know how does that research contribute to those specific sustainable development goals. We could, of course, do one thing, which would be to label all research papers with regards to sustainable development goals so that we can understand then where do we contribute. Maybe different universities contribute towards different goals, and if we know how to contribute it, how to find those papers, basically, then we can also better communicate what universities are doing in order to progress. So that's why we realize that manually sort of labeling papers is incredibly tedious, and therefore we wanted to develop an AI model that would do this labeling very, very quickly, yet still accurately. So at the Open University, we also have something called the Open Societal Challenges platform. This is a really nice program, basically, within the university where we are sort of supporting, where we're supporting basic projects which are supposed to contribute towards the society, and we are feeding these labels to the to this platform, basically. But perhaps if you are from another university, that part is not at this point so important. What I want to show you is basically that we take research outputs basically from our institutional repository called the Open Research Online, and but we take basically outputs from any other repository in the world. We then run it through, pass it through an AI SDG classification tool, which is based on this encoder architecture. We get multiple, one, actually doesn't have to be always one. It could be 0 up to n United Nations Sustainable Development Goals labels, and then we feed it into a new dashboard tool. Any institution in the UK can get access to this dashboard tool if you are interested in that. This is how the dashboard tool looks like, and I'm going to give you a little bit of a demo, as I said before, but it effectively gives your university an overview of how of which papers in which group you have more. So you can take scope, you can make decisions, and so forth. There were many technical challenges in developing this model. So some of them are based on the idea that previous models for automatic classification into sustainable development goals are only based on keywords, and keywords are incredibly imprecise. So there is, for instance, a model, I think, which is part of the Scopus package, and that is not using machine learning, and therefore the quality of that model is not so good. So we wanted really to have a supervised model. We also realized that there are some existing models which only classify, you give them an output and it only gives you up to a maximum of 1 label. That also wasn't sort of sufficient for us, because we thought that it is important to recognize that some papers can contribute to more than one sustainable development goal. So we wanted something which is called a multi-label classification model. And we also, because in CORE we have 300 million plus scientific records, basically, we needed something that operates incredibly quickly. We could not afford, or we would not be able to afford, to run everything via a large language model, even if we wanted to, because that would ruin us. So we wanted something that is really fast, and that's why we went for this encoder architecture. This is how it looks like. I'm going to, our model is based on something called SentenceBird. SentenceBird, for those of you who are who have technical background, SentenceBird is an encoder architecture which is really still state of the art. It projects the text into the text you supply to it to a multidimensional vector space. Where basically those papers which talk about similar things then effectively will be close to each other. And we fine-tuned this SBIRD model using a new database that we created by manually labeling 500 papers from the Open Research Online repository. And this labeling was actually quite challenging, but I don't think I have the time to talk about this, so I'm going to skip this. But I'm going to now skip to the last slide. But before I go there, I'm just going to attempt to move the to share with you the actually. Yes. Hopefully, I'm sharing the tool. So this is how the tool looks like in the CORE dashboard. So this is how it looks like for the Open University. And you can see that, in the Open Research Online repository, there's about 50,000 or 60,000 records, something like that. So not every paper necessarily is linked to an SDG, but many papers are. So you can see that, for instance, we labeled automatically 25,000 papers using SDG labels. So, just below 50% of our papers are related to some or to at least one sustainable development goal. You can then click, for instance, on a specific sustainable development goals. I can, for instance, I selected good health and well-being, and then I see how it compares to all of the outputs. I can compare multiple things. As you would probably not be so surprised, the Open University does a lot of research on quality education. I can also look at SDG overall distribution, so I can see how what's the profile of our university, and so I can see that, for instance, we do a lot of quality education partnership for the goals and good health and well-being. I can then also look at specific papers, so I can, for instance, say, oh, I'm interested in this particular paper, and I can see that it's been labeled with 2 sustainable development goals, and for each of them, we generate something called a confidence score. So sadly, the labeling against sustainable development goals is actually quite it's quite a difficult process, which is to some extent subjective. So humans agree to something like 0.6, or so at about 60% they agree on these labels. So we thought it was very important to show and be transparent about the confidence scores for these labels. And when you go there, you can of course then directly go, for instance, to the repositories. If I clicked, I will be redirected to our repository, Open Research Online, to be able to see exactly that paper, or I can open it in CORE. So that's all about this. I will go back to the slides. I'll try to do it quickly. Yes, okay, I'm back. So the key thing about the key contributions of this are that we've created a new machine learning model for sustainable development goals labeling. We are just creating a research paper in which we actually compared this model with some other models, and we have seen quite significant boost in performance over existing models. But I will not speak about this because the paper is coming out basically soon. We have embedded it into a dashboard which other institutions can use, and the data can also be available over an API if someone is interested. And with that, I'd like to move to the last part of the project. This is about a project that is very closely related to reproducibility of research. And it is a project which is funded. Actually, let me give you an intro, and then I'll tell you how the project is funded. So more than 70% of researchers, according to a study of Baker from 2016, have tried and failed to reproduce another scientist's experiment. So many of us have been here basically and failed to do something that other people have done and getting the same results. But what is even more staggering is basically that 50% of researchers have failed to reproduce even their own experiments. And the majority of people, of researchers who were surveyed basically in this very well-known study from 2016 said that that they actually consider that there is within science that there's a considerable sort of reproducibility crisis. So what can we do about this? What can we do about this? So there are many things that can be done about this. But when these people were asked about what can be done, then many of them said that not being even able to find the source code for those studies is effectively preventing them to reproduce experiments. And this is the problem that the software project is trying to sort of, I don't want to say just solve, but contribute to solving, because there are many things that need to be done here. But so one of the many issues that are hindering reproducibility and sort of discoverability of open research software is actually that the existence of the software itself is often hidden and remains hidden within the manuscript of research papers. So when we think about what libraries tend to do, and what researchers tend to do, we are usually very good in putting a lot of effort in writing research papers and curating these research papers and putting these research papers into repositories, giving, attributing metadata to these research papers and so forth. There has been a lot of discussion about the fact that we need to be doing exactly the same thing about research data, and I think that we are moving in the space towards doing it for research data. But in fact, there is a third asset, and that's software, research software, which requires the same kind of level of curation, basically, and care. And sadly, I feel that the research community has not been really taking care of research software in a particularly good way. So what we need to start really doing is we need to start treating research software as first-class bibliographic records. And once we start doing that, we will be able to link every research paper to the research software that was used within that paper. So the software project is a 2-year Cistira funded project. This is an international EU project. The Open University is a coordinator in this project. It actually happens to be myself, and we collaborate with an institution in India, France, with the Brno University of Technology, with IBL PAN in Poland, and also with Europe PMC in the UK. So we have 4 countries. And there's one thing which I would like you to remember about software, and that's actually the workflow, which I want to show you and tell you about right now. So what normally happens is that there is a particular workflow in terms of which sort of shows how manuscripts how research manuscripts are basically handled in repositories, and that workflow can be, let's say, adapted to take care of research software in a similar way. And that's what we are sort of attempting to do here. So normally what happens is that an author at some point writes a research paper and deposits, an author at some point, as they are working on producing a research study, they usually have some software which basically they deposit they typically deposit it in many commits to a code repository, which can be, for instance, GitHub. Then the author, at some point, when they write the research paper, they deposit the manuscript into one of the many open access or institutional repositories. And in that paper, they will typically put one sentence, maybe, where they will say, by the way, for this study, I used the software. Sometimes they put the URL to GitHub. Not always they do it, but sometimes they do. So that's the sort of first step. Once it is in a repository, we can do one thing that could help basically facilitate the better curation. So CORE aggregates or indexes that paper, and we can use a machine learning model to find that specific mention of the source code, of the use of the software, basically. How can this look like? So this sentence can look like this. For instance, this is the research paper, and I can see that there's a sentence which says the Advion Chipsoft X software was used to capture an optical image of the prepared slide on a flatbed scanner prior to analysis. And what we would really like to do is for the AI language model to effectively extract that Advion is the publisher or the creator of the software, and that Chipsoft X is actually some piece of software. And ideally, we would also like to get a link to that software somewhere. And so once we have that, we actually put this information we represent this information in the core repository dashboard. The core repository dashboard is typically used by repository managers. And what we want these repository managers to do is to just allow us basically as core to push notifications about new research software to their own repositories. So effectively, we want them to authorize us to be able to send to their repositories information that we found that their academics have created new software which should be archived, basically. So you can probably imagine that core, at some point when we discover that a new software has been created by an academic from a particular institution, we can send some sort of a notification to that repository. And at that point, that institution can send an email back to the author, which effectively says something along the following lines. We found that you might be an author of this new software. We have extracted automatically the metadata for you, and we would like you to confirm that that is the case, because of course AI can make mistakes, and we don't want to propagate mistakes to archives. So we want to do this. What you might ask the question of why would core not send the notification directly to the author? Well, multiple reasons. First of all, if I, as an academic, get an email from my own institution, I really trust it. I will probably respond, especially if my institution asks me to do something. So it becomes an institutional if it becomes an institutional policy thing, people will probably do it. And of course, an institution will always have the email address for the author, basically. So that's another reason. Core doesn't always have the email address for authors of scientific papers, even though we might have email addresses for corresponding authors. Once it has been established that the research software is being created by a particular person, by a particular author, and then that author can, of course, get something for it, because they can also get the credit for the fact that now they will be recognized as authors of this research software. There can be an automatic notification to an archive called Software Heritage, which effectively archives the source code from the, let's say, GitHub or another source code repository. There are many code repositories. GitHub is of course one of the most widely used, but there are probably 50, 100 plus code repositories like GitHub. So I'm sort of quickly moving towards the end of the talk. So I just wanted to, just to conclude this, from my perspective, I think that identifying and archiving software assets is really, really important. We should be doing it. It matters, because if we cannot make research reproducible, then this will decrease the perception of the society and sort of the trust in research. So if we want researchers to be trusted, we should do as good of a job as we can to make it as reproducible as we can, and doing it, of course, shouldn't make the process particularly onerous. So it is valuable, in my opinion, to make use of AI in this space to help us with these administrative tasks, which otherwise would be very difficult to do, because putting another burden on academics is difficult. I'd like to generalize a little bit. So you have seen now 3 talks, basically, or three projects that my group has been sort of involved in. And I'd like us to sort of understand that, there are many challenges in which for the use of AI in academic research, and some of them I have listed here. There are also many opportunities of AI for academic research. If we think about what researchers tend to do about the kind of processes, typically research starts with some sort of doing a literature review, and then researchers are involved in hypothesis generation, and then they probably create experimental code, and they need to experiment, and then they need to interpret the data, and then they will draft manuscripts, and then there will be something about they will be submitted to a peer review. And the research process will then involve some sort of assessment, and there will be a process of dissemination. There are probably other processes which I have missed, but this kind of shows a little bit the life cycle of research. And if you think carefully about this, then you will probably be able to imagine that every single step can these days be facilitated by AI. I'm not suggesting that it should be replaced by it. I'm just saying that we can imagine AI being used to support the researcher in every single step here. And as a result of that, I believe that research processes will dramatically change over the next 10 years. Hopefully they will change for the better, and hopefully it will be the case that we will live in a period of almost exponential exponential research discoveries, basically. So there's good hope that many new things will be discovered over the next years thanks to AI. That's all from me. Before I finish, I'd like to thank a lot the members of the core members. Without them, we would not be able to do the research which I have presented here. We would not be able to run core. Core members are institutions that kindly donate resources to the core team to be able to run core, and we really appreciate this. Yes, and on that note, I would really like to finish and hand back over to the organizers. Thank you so much.